All right, so the 5.1 is the beginning of trig identities. Kind of a tough unit, so from the beginning we got to start making sure we know what's going on. We have reciprocal identities, which we probably already know. Like, remember, if we want to do secant on a calculator, you'd have to type in 1 divided by cosine of the angle. The quotient identities, tangent is sine over cosine, cotangent is cosine over sine. And there are 3 Pythagorean identities. Each one, though, could be switched around. So you could take, for instance, you could take the cosine squared to the other side, and that would leave sine squared of u is equal to 1 minus sine squared of u. So we don't write all of them out, but I refer to those as rewrites. So you go back and grab the Pythagorean identity, and you may have to move one thing to the other side. All right, so for instance, if we were going to start here, I might go, oh, well, there's a cosine in both terms. So if I factor out a cosine of x, that would leave behind sine squared of x minus a cosine squared of x. Well, looking at Pythagorean identities, I could take sine squared, oops, I wrote this wrong, I moved the cosine squared, sorry. I moved the cosine squared to the other side earlier. All right, so if I want to take sine squared, it's the same as 1 minus cosine squared right here. But I did not do anything with this cosine, and I did not parentheses there, and I did not do anything with this cosine squared here. All I did is change sine squared into 1 minus cosine squared. Now, if you distribute the cosine, or leave cosine, let's leave cosine of x there. Inside here, these two add up to 1 minus 2 cosine squared of x. But because that indicates multiplication, I actually just have one term. So I combined the original 2 terms into one term. And we consider that simplified. Not always looks the best, but it is simplified. Something similar here. Let's see. We got a cosecant in both. And if I pull that out, it leaves behind 1 minus cosine squared of x. Now we just saw that this 1 minus cosine squared is actually sine squared of x. And another way to write cosecant is 1 over sine. So if you're going to multiply these two together, you can put that over 1, and you end up with sine squared of x over sine of x. Or you could just cross 1 off, just like you would here. There's 1 here, but you're still left with sine of x on top, 1 on the bottom, or sine of x. Similar looking problem, secant in both. Let's pull that to the front. So now I have sine squared of x minus 1. So if I go to that Pythagorean identity where it was sine squared of x plus cosine squared of x is equal to 1, and I move the sine to that side, it's close to what I have over here. So look right in here. A lot of times students make that mistake. They're not the same. So what you have to do is multiply everything by a negative 1. And what that will do is the positive 1 becomes negative, and the negative sign becomes positive. So basically by multiplying by negative 1, I switch the order. Now it's the same. So now I have 1 over cosine times negative cosine squared. You can put that over 1 if you want, and when you do your crossing off, you're left with a negative cosine squared of x. Factoring and simplifying the trig expression. So factoring is just like we would with quadratics. Nothing big here. I'm going to do, this is a difference of squares. So I can do secant of theta minus 1, secant of theta plus 1. So remember, if you FOIL, these two things would multiply and they add up to 0. So there's no middle term up here. So that's what's happening. Simple factoring. Example 2, it's a DIY. So you're going to do the answer, come back and check. Pause the video now. All right, so let's go take a look at that answer. Right here, I would do, it's a squared minus a squared, so sine, cosine, but one's positive, one's negative. Difference of squares factoring. All right, so this next one looks like a quadratic, so I can do a tangent of theta and a tangent of theta. Now my factors are 1 and 3 here, 1 and 4, 2 and 2. So I'm just going to start with a 2 and a 2, and looking at it, if I have to add up the 1 in the middle. If I do a 3 and a 1, it's probably not going to work. So I don't think the 2 and 2 will work. So let's try putting in 1 and a 4. And if I make this 3 and 1, now you have 4 tangent here, and out here you have 3 tangent. And I need a positive 1 in the middle term, so I make this positive. So that's positive, that's negative. There's your factoring. The next one looks like a quadratic, except it's got a couple different terms in it. It would be like an x and a y, so we got to be careful with that one. So what I would do is go to the second Pythagorean identity, which is the third one, which is 1 plus cotangent squared of x is equal to cosecant squared of x. And I'm going to take this 1 to the other side. Nope, we don't need to do that. I can just leave it like this. So what I can do, though, is I have a cosecant squared and a cotangent. If I make this that, so I can bring this over, 1 plus cotangent squared of x. I didn't touch these. Let's make them red. I didn't do anything to these two. So notice how I replaced the cosecant squared with that in my problem. Now I only have cotangent in the problem. So if I distribute, I have 2 plus 2 cotangent squared of x minus a cotangent of x minus 3. These are like terms. So now you have 2 cotangent squared of x minus a cotangent of x minus 1. If you want a chance to factor this, I'm going to ask you to pause the video and then I'll show you the answer. So if you want to look at it, pause it now. So you had a chance to pause it. If I was going to factor this, I would put a 2 cotangent first. And I would do a cotangent here. The only way I'm getting 1 is to have 1 and 1. And I need a middle term that's negative. So the outside term has to be negative. The inside term is positive. And there's a good factoring. Okay, so this last example, it just says simplify. We're not doing any factoring here. So we're going to try to put these two terms together. And right now, I have 3 different trig functions. So I'm going to write this as sine of t plus cosine of t over the sine of t, that's my cotangent, times cosine of t over 1. So right away I have sine of t plus cosine squared of t all over the sine of t. Now it'd be really nice if I could get a common denominator, and that's very easy because right now this denominator is 1. So if I multiply the top and the bottom by sine, I get sine squared of t over sine plus cosine squared of t over cosine, over sine. Now that the two denominators are the same, I can go ahead and add the numerators. So you have sine squared of t plus cosine squared of t all over sine of t. Well, hopefully you recognize this already. Sine squared plus cosine squared is 1. That's the number one Pythagorean identity. And another name for 1 over sine is cosecant. So that's how we simplify that last one. Much nicer to work with cosecant than the original expression. Okay, so we have another example. It says factor. So when I look at the top equation, right away that's a difference of squares. So I'm going to just do cosine of x minus 2 and cosine of x plus 2. And we still have cosine of x minus 2 on the bottom, in which case I can cross those off and I'm just left with cosine of x plus 2. So that's pretty straightforward simplifying. You're going to do the next one on your own, DIY. And what I'd like you to do is change everything into terms of sines and cosines. We have a lot of, well, maybe we can factor out the secant. Either change everything to sines and cosines, see what happens, or do the secant, and let's come back and check your answer. So pause the video now. Okay, so this is what we talk about. There are multiple pathways through this problem. If you change everything into sines and cosines, you'd have 1 over sine, 1 over cosine, sine, 1 over cosine. So this term is sine over cosine, and if you multiply these two, you get 1 sine over cosine. So what do we have in this denominator that we're missing over here? The sine. So multiply the top and the bottom by sine. So now you have 1 over sine cosine minus, notice how we're just looping right to here. And this is sine squared over sine cosine. So the denominators are the same. So the denominators stay the same. Now the numerator then becomes 1 minus sine squared. Well, that's one of the rewrites of the number one Pythagorean identity. So 1 minus sine squared is cosine squared. And if there's 2 cosines on top and 1 on the bottom, when you cross them off, you still have a cosine on top and a sine on the bottom, which is cotangent. Now this one, this was the second option. You can go ahead and factor out a secant. So another name for secant is 1 over cosine. You left behind a cosecant, which would be 1 over sine. And you factored away the secant and you're left with just sine. If you want to add these two together, or subtract them in this case, you would try to get a sine denominator. So right now it's 1. So if you multiply by sine on top and sine on the bottom, you get sine squared over sine. Now add those two together, in this case subtract them, and you have 1 minus sine squared on top over sine, which is cosine squared over sine. Get rid of 1 here, get rid of 1 there, cosine over sine, cotangent. So a lot of times there are multiple pathways through it. You just want to, you got to practice these things. All right, so cotangent squared over cosecant squared. Let's see what we can do here. I might start by writing cotangent squared as cosine squared of theta over sine squared of theta. And on the bottom, cosecant squared is the same as 1 over sine squared of theta. So what I really have now is cosine squared of theta, sine squared of theta, times sine squared of theta over 1. When I'm dividing by a fraction, I can multiply by the reciprocal, and I cross those off, and I have cosine squared of theta for my final answer. All right, so the last one is to try to get rid of fractions. And we have a technique that we used back with a conjugate. So working with complex numbers, we often multiplied by the conjugate of the bottom, and this is similar to that. So if you multiply, you end up with 1 minus sine of x on top, and on the bottom, you only have to do first and last. You don't have to worry about the middle term. It's just 1 minus sine squared of x. So now this right here can be written as 1 minus sine of x all over cosine squared of x. And I call it a heart, break it apart. So 1 over cosine squared of x minus sine of x over cosine squared of x. And I would do one more thing right here. This term can actually be written, so I have 1 minus cosine squared of x minus. Now there are two cosines on the bottom. So I could do 1 over cosine times sine over cosine. If you factor that, I guess. So another name, what's another name for 1 over cosine squared? Secant squared. Another name for cosine is secant. And another name for sine over cosine is tangent. Now technically that's two terms, and if they both have secant, I could actually factor a secant out, and that leaves behind a secant of x minus tangent of x. Technically, the green one is down to one term because of multiplication, but the beginning was get rid of the fractions. So the light blue is fine if you got rid of the fractions, but this one is more simplified. It's only one term. All right, let's try it once here. So I have sine squared over 1 plus cosine. I'm going to multiply by 1 minus cosine. And I'm going to write it as sine squared times 1 minus cosine of y all over 1 minus cosine squared of y. I only have to do first and last when I do my conjugate of the bottom. Now the cool thing is that this thing on the bottom right there, I have a sine squared of y, 1 minus cosine of y all over. Remember, 1 minus cosine squared is sine squared of y, which you can cross off, and so I'm left with 1 minus cosine of y. No fractions. And that's it.